So what happens there is let's say the data from this third task here goes back into Delta Lake, which is still underlying S3 storage, right? And we were able to integrate Wherobots, which by the way work fantastically, which we'll see in a second, to essentially seamlessly just go and using the Delta Lake from Spark again, run the spatial join task, and you can essentially just poll that job just to make sure that things are going as intended, and then it essentially puts it back into S3 for the further tasks to take on with. The reason that this is very powerful is because it comes really much into cloud native in the sense that the data doesn't necessarily leave our AWS environment. It's still there. It's essentially just a compute which comes in, which is very powerful as part of the Sedona and the way the Wherobots will optimize that. If we go into this is essentially what the spatial join kind of looks like. You can just imagine this is a map with the various points here being restaurants, essentially restaurant locations, and they being from various sources. So, color red, green, and yellow, blue, for instance. So one of the things that we use is the D within, which essentially means, okay, taking this red point, for instance, find all similar restaurants which are nearby, maybe within a 250-meter radius, right? And what essentially comes there together. So what are the nearby restaurants? And the kind of assumption here is that, whatever you're trying to match in terms of the same restaurant from multiple sources, they are probably very close to each other. So really based on the kind of radius that you take, you can take a bunch of nearby restaurants for any source, and then assume that they're going to be part of the kind of total universe of restaurants that you have to check to make sure that it's part of the same physical restaurant, so to speak. So, as part of as Sedona syntax goes, it's quite easy. If you probably come from something like PostGIS or just working with geospatial SQL, this is going to look very familiar. You just pass in the geometries, in this case, the points and the radius, and you essentially can get to work. So it was definitely quite powerful. But really, most of the power came from how fast this was able to run, right? So before we were on Wherobots, we still had this use case, and we used to use BigQuery. And this was to, for example, on the United States countries level, we had a bunch of sources that had restaurants, right? So maybe there was a single online source that had 850K restaurants, and another one that had a lot, maybe some had very less. But the idea being that we had to bring all of these together, right? And essentially at the end of that matching process, all of these can kind of conflate, as we were talking about, to 1.1 million restaurants. But one of the starting steps to that is to find the nearby points and then figure out how the matches work. So when we were doing it in BigQuery, we had to put data into GCP. So it was very, I guess, kind of like it was a bit prickly. It was like, oh, why is data, leaving this environment and system? Why doesn't the compute just come here, right? But still, and another thing is we had to partition by state, meaning only process each state individually. So, any restaurants that were at the border of two states were instantly, primed for mismatches, right? And of course, we could essentially run multiple states concurrently, and we could, do a bunch of source comparisons. In this case, we were using on-demand, so not the dedicated slots with BigQuery, and this took a lot of time, right? Just to process all of these restaurants and kind of do that operation we saw on the previous slide about just finding nearby restaurants was about 4.5 hours, so quite big. So when we essentially switched to Wherobots, which again was, where, as you saw with the previous, that slide, the data still resides here. So the compute is able to use it, it processes it in memory, and then it essentially is putting it out. And here we don't have to process by state, and we can partition it any way we want. It's going to be much more flexible. And then we end up with about an 18 minutes runtime, which is just significantly better. And again, kudos to the Wherobots team. They were a huge help, both in terms of helping us get it set up with this, as well as what's essentially being built here. Finally, that essentially helps us end up with a beautiful restaurant map that looks like this, with all of the over 1 million restaurants in the United States, which are matched by source and with the various features. So I'm just gonna kind of leave that there.